Welcome back everyone. I am Ashok. So in this video we are going to cover the remaining portion of time and work. This is going to be the last video in this series. Okay, let's get started. So in the previous class we stopped at this problem. Now we are going to continue from here. That is joining and leave case. That means some people are going to start the work. Okay, after some days some going to leave, and after some days some may join. Like this. If they are working like this, how long they will take to finish the work? You need to find out in these kind of problems. I'm simplifying it. Here some people are going to start the work and some may leave in the middle or some may join in the middle. So if it happens like this, how long they will take to finish the work? So let's get started. See here, A can finish certain piece of work in 8 days. B can finish the same work in 12 days. So whatever may be the problem, the first step is always going to be the same. You need to find out the LCM, then you have to continue. Okay, first let's finish the problem. They started working together. After 2 days, A left the work. That means let us take they started working here, okay, together. Okay, after working for 2 days, A left the work. That means now only B is working from this point. Okay, how many days rest of the work will be finished? Okay, next, in how many days the remaining work is going to be finished, that you need to find out here. Okay, or if I want to say simply, how long we need to work more to finish the remaining work. So for this, what we are going to do is, we are going to assume this problem in our chocolate problem terms. Assume that we are having chocolate packet. In that packet we are having some chocolate. A and B opened the packet together. After eating for 2 days together, A stopped eating. That means remaining packet has to be finished by B. You need to find out how long B will take to finish the remaining packet, like that. So first what you need to do is take the LCM. It's going to be 24. If assume that you are having 24 chocolates in the packet. So if A can eat 24 chocolates in 8 days, means per day he can eat 3 chocolates. B can eat 2 chocolates per day. Now how you are going to solve this problem is simply like this. We are having only 2 people here. So if you add chocolates eaten by A and chocolates eaten by B, you should get the total number of chocolates, because only 2 people are finishing the work. Just find out how many chocolates A is eating and then find out how many chocolates B is eating. The sum should be equal to total number of chocolates in the packet. In our case, that is equal to 24. So see, A left the work after 2 days. That means that A is working for 2 days. So chocolates eaten by A plus chocolates eaten by B should be equal to 24. So A is leaving the work after 2 days, means in 1 day A can eat 3 chocolates. In 2 days A can eat 2 into 3, 6 chocolates. And B is working for first 2 days as well as next X days. So B is totally working for 2 plus X days. Per day he can eat 2 chocolates. So like that they are completing all the 24 chocolates. So 6 plus 4 plus 2x is going to be 24. 2x is going to be 14, x is going to be 7. That means after A left, B need to work for 7 more days to finish the work. Okay, I hope this one is clear. What we are doing here is, we know that only 2 people are finishing the work. So work done by A and work done by B. If we add both of them, that should be equal to total work, which is nothing but 24 in our problem. So A is working for 2 days with the speed of 3 units per day. B is working for 2 plus x day with the speed of 2 units per day. Simply find out the value of x. Okay, let's move on to next one. Let's solve the next problem. In this problem we are having A can do the work in 16 days, B can do the work in 20 days. They started working together. Okay, in how many days before completion of the work B should leave, so that the work will be finished in 10 days. That means they want to finish the work in just 10 days. But if they want to finish the work in 10 days, how many days before completion B should leave the work, so that the work will be finished in just 10 days. Guys, remember, from here he is asking from ending point of view, how many days before completion. Let us take x days before completion B is leaving the work, so that work will be finished in total 10 days. If this is x, this value should be equal to 10 minus x days. So the first step is simple, simply find out the LCM. So this, let us take 160. You can take any number that will cancel both the given days. Okay, so 160 chocolates A can eat in 16 days alone. That means he can eat 10 chocolates per day. 160 chocolates B can eat in 20 days alone. That means he can eat 8 chocolates per day. Now think like this. Chocolates eaten by A and chocolates eaten by B. If you add both of them, that should be equal to total number of chocolates in the packet, which is nothing but LCM in our problem. So think like this. See guys, here B is leaving somewhere, but A is not going anywhere. A is there in the starting as well as A is there in the ending. That means A is there for 10 days. So in one day he can eat 10 chocolates. In 10 days he can eat 10 into 10 chocolates. And B is there in the problem only for 10 minus X days, because he left X days before completion of the work. That means he is there in the problem for only 10 minus X day. In one day he can eat 8 chocolates. So this should be equal to 160. So 100 plus 80 minus 8x should be equal to 160. So minus 8x should be equal to 160 minus 180, that is minus 20. So x should be equal to 20 by 8. Okay, which is nothing but 10 by 4, 5 by 2, which is equal to 2.5 days. That means that B should leave 2.5 days before completion of the work. Then only it is possible to finish the work in exactly 10 days. Okay, so this is our joining and leaving problem. What you need to do here is simply take chocolates eaten by first person, chocolates eaten by second person should be equal to total number of chocolates. So how many days are they working? Multiply that with number of chocolates. Okay, similarly, how many days B is working? Multiply that with number of chocolates. That should be equal to your total number of chocolates. That's it. Simply find out X value, you will get your answer. The next model is alternate days. That means one day someone is going to work, next day some other guy is going to work, on the third day again first guy is going to come, like this. So let us take A is starting working, then on the second day only B is going to work, on the third day again A is going to work, on the fourth day again B is going to work, like this. They are going to work on alternate days, like first day, second day, third day, fourth day, like this. So if they are working like that, how long they will take to finish the work? Okay, let's go. A can finish certain piece of work in 18 days. B can finish the work in 24 days. Okay, they started working alternatively, starting with A. In how many days work will be completed? That means A is starting the work, then B is working, then A is working, then B is working. If they are working like that, how long they will take to finish the work? Let's go. What are the LCM of 18 and 74? Let's take, we're having 72 chocolates. A can eat 72 chocolates in 18 days, means 4 chocolates per day. If B can eat 72 chocolates in 24 days, means he can eat 3 chocolates per day. Now, first day A is eating, so he can eat 4 chocolates. Second day B is eating, he can eat 3 chocolates. So if they are eating like this, how long they will take to finish all the 72 chocolates? That's what you need to find out here. So if you observe here, in 2 days they can eat 7 chocolates. That means 1 more 2 days, 1 more 7, 1 more 2 days, 1 more 7. So what you need to do here is try to go to the nearest multiple of 72. Okay, try to go to the nearest multiple of 7 that is nearer to 72. So this gonna be 10 times 70 chocolates. If you are getting 10 times cycle like this, means you are getting 10 times 2 days, that is nothing but 20 days. That means by the end of 20th day you can complete 70 chocolates, but still we need to cover 2 more chocolates. So on the 21st day, who is going to work? Again A is going to work. Okay, in A, in one day he can eat 4 chocolates, but we need to finish only 2. How long he is going to take? He is going to take only half day. That means that we want 20 complete days along with half extra day. So total is going to be 20 and half days. So guys, I'm repeating once again. So what you need to do in these kind of problems are, how they are doing the work. Assume that in the same way you are eating the chocolates. So A is eating on first day, B is eating on second day, and again A is eating on third day, B is eating on fourth day, like this. Okay, so take the LCM as total number of chocolates, and now say convert the problem like this. A can eat 72 chocolates in 18 days, B can eat 72 chocolates in 24 days. How long they will take to finish these 72 chocolates if they are eating alternatively? Think the problem like this, then solve. So 72 chocolates 18 days means A can eat 4 chocolates per day and B can eat 3 chocolates per day. So A is eating 4 chocolates on first day, B is eating 3 chocolates on second day. That means in 2 days they can eat 7 chocolates. So go to the nearest multiple of 7, that is nearer to 72. You can go up to 70. That means 10 times. So if you are getting 10 times cycle like this, means you are getting 10 times 2 days, which is 20 days. So by the end of 20th day, you can complete 70 chocolates, but we need to eat 2 more chocolates. So on the 21st day, A is coming to work. So in one day, he can eat 4 chocolates. To finish 2 chocolates, how long he is going to take? Only half day. So we want 20 complete days along with half extra day. So the answer is going to be 20 and half days. Let's move on to the next one. Okay. A can finish certain piece of work in 12 days, B in 15 days, and C in 20 days. Okay, A and B started working together. Okay, A and B started working together, and they are assisted by C on every alternate day. It means on the second day, along with AB, C is going to help them. Again, AB, again ABC. They are working like this. If they are working like this, how long they will take to finish the work? That's what you need to find out here. So the first step is very simple. Simply find out the LCM. We're having LCM as 60. So A can eat 60 chocolates in 12 days, means 5 chocolates per day. B 4 chocolates per day. C 3 chocolates per day. So first day AB is eating, so only they can eat 9 chocolates. Second day ABC eating, that means they can eat 12 chocolates. So if you observe here the cycle is getting repeated. So you can write like this. In 2 days, they can eat 21 chocolates. Now what you need to do here is go to the nearest multiple of 21 that is nearer to 60. So the multiple of 21 that is nearer to 60 is 2 times only. That means 42 chocolates, that's equal to 4 days. That means by the end of 4th day, we can complete 42 chocolates. 42. But we still need to complete 18 more chocolates. So let's go to 5th day. On the 5th day, AB is going to work there. They can eat 9 chocolates in one day. So we're already done with 42. Now we are completing 9. That's going to be 51. So by the end of 5th day, we can complete 51 chocolates. We need to cover 9 more. So let's go to 6th day. On the 6th day, ABC are going to work. But in one day, they can eat 12 chocolates. But we need to finish only 9. How long they are going to take? This is going to be 9 by 12, which is equal to 3 by 4 days. That means we want 5 complete days along with 3 by 4 on next day. So the answer is going to be 5 3 by 4 days. That's it. Simple thing, guys. Take the LCM. Assume that you are eating the chocolates. However they are working, assume you have to work like that to finish the packet. That's it. You will get your answer. Okay, let's go. The last one in our discussion of time and work is pipes and cisterns. So all the problems on type and work are similar to all the problems on pipes and cisterns and vice versa. So the problems are going to be like this. Tap A can fill a tank in 10 hours. Tap B can fill the tank in 15 hours. How long they will take if both of them are opened? Like in our problem, like different efficiency problem. Similarly, let us take you are having 2 pipes. If you open these 2 pipes, they are going to fill the tank in 10 hours. If you open these 3 pipes, they are going to fill the tank in 15 hours. If you open 1 pipe from first A section and 2 pipes from B section, how long they will take to fill the tank? That's similar to our group of people problems. So the only difference between time and work and pipes and cisterns is there may be a chance of having leak in pipes and cisterns. That means if you are considering the topic of time and work, okay, there is nothing called destruction of work. That means nobody is going to spoil the work that you have done. But in this case, what is happening here is you may try to fill the tank, but because of the leak, some of the water may come out. So you have to consider that leak also while filling the tank. That's the only difference. So let us see how you are going to solve these kind of problems. So just for an example, I am going to give you a simple problem. Think like this. A can fill a tank in 10 hours. B can fill the tank in 15 hours. How long they will take if both the pipes are opened together to fill the tank? Now, what you are going to do in LCM problem, take A can do in 10 hours, B can do it in 15 hours. Assume the LCM as tank capacity. That means, assume we are having 30 liters tank. If you open tap A, it can fill 30 liters in 10 hours, means it can fill 3 liters per hour. If you open tap B, it can fill 30 liters in 15 hours, means it can fill 2 liters per hour. If you open both of them, they can fill 5 liters in 1 hour. So in 1 hour, if they can 5 liters to fill complete 30 liters, how long they are going to take? Simply 6 hours. Simply cross multiply, you will get 6 hours. So the same process, you are going to take the LCM. So instead of taking number of chocolates per day, we are going to take the speed of the pipe, like 3 liters per day, 2 liters per day. So whatever the pipes are opened, you are going to assume the sum of their capacities as total speed. Like here in this case, A speed is 3 liters per hour, B speed is 2 liters per hour. If you open both of them, they can fill 5 liters per hour. That's it. Now see, I will add one more thing. Let us take, you are having an empty tank. If you open tap A, this can fill the entire tank with water in 10 hours. If you open tap B, it can fill the entire tank in 15 hours. But there is a leak on the tank. Okay, this leak can empty the entire tank in 30 hours. That means if the tank is full, then what will happen here is, because of the leak, it can empty the entire water in the tank in just 30 hours. So due to some reason, if all the three are acting together, that means tap A is open, tap B is open, as well as leak is also there, then how long it will take to fill the tank? Let us see. So 3 pipes, filling 10, filling 15 and emptying 30 hours. So what you can do here is, you can do the same process, A equal to 10 hours, B equal to 15 hours and C equal to 30 hours. But in order to distinguish between filling and emptying, take emptying as minus. Okay, so then what you are going to do? You are going to take the LCM, 30. Assume that your tank capacity equal to 30 liters. A can fill 30 liters in 10 hours means 3 liters per hour. B can fill 2 liters per hour. But C can empty 30 liters in 30 hours means it can empty 1 liter per hour. So I am taking minus just to indicate that's a leak or emptying tap. So that means what will happen after 1 hour? This is going to pour 3 liters. This is going to pour 2 liters. This is going to empty 1 liter. So as a result, you are going to have only 4 liters inside. So see here, add all of them because you are opening all of them. So add all of them, you are going to get 4 liters per hour. So 3 plus 2 minus 1. That means if you open all of them, you can fill only 4 liters in 1 hour. So to fill 30 liters, how long you need? Simply do cross multiply. So 30 by 14, 15 by 2, which is equal to 7.5 hours. That's it. Simply take minus, then every problem is going to be the same. I will just give one more example. Assume that A can fill the tank in 10 hours, B can fill the tank in 15 hours, C can empty it in 6 hours. Then if you open all of them, what will happen? See here, 30 is the LCM, 3 liters per hour filling, 2 liters per hour filling. So 30 liters 6 hours means it can empty 5 liters per hour. That means that whatever the speed of the inlet pipe, that's equal to the speed of outlet pipe. As a result, there is going to be net zero inside the tank. That means whatever the water coming from the inlet pipe, the same water is going out of the outlet pipe. So because of that, there isn't going to be any change in the position of the tank. I will explain what is meant by any change. So let us take, if the tank is empty, there is no water in the tank. If you open all the 3 pipes at that time, then what will happen? The tank will remain empty. Let us take, you are having off-filled tank. If you open all the 3 pipes at that time, whatever the water coming in, the same water will go out. That means the tank will remain as off-filled always. So if he is giving, if you open all the 3 pipes, when the tank is empty, what will happen? You can simply say the tank will never get filled. We'll solve one more last case. A can fill in 10 hours, B can fill in 15 hours, C can empty in just 5 hours. Then the LCM is going to be 30, 3, 2, you are going to get minus 6. That means as a result, minus 1. So minus indicates that the outlet pipe capacity is much higher compared to inlet pipe capacity. That means simply saying inlet holes are small and outlet holes is much bigger compared to inlet. That means whatever the water coming in from the inlet pipes, it has the gap to send the entire water out, as well as there is some more gap left out. Now in this case, what will happen? If you open all the 3 pipes, when the tank is empty, okay, the tank will never get filled. Let us take the tank is off filled. That means let us take, there is already 15 liters water inside the tank. Now if you open all the 3 pipes at that time, what will happen here is, whatever the water coming in, this will go out anyway. Along with that, for every 1 hour, 1 liter is going to subtract from this 15 liters. So after 1 hour, it's going to be 14. After 1 more hour, it is going to be 13, then 12, like this. So minus indicates that the outlet pipes faster compared to inlet pipe. So if it is empty in tank, the tank will never get filled. But if it is already somewhat filled tank, then the original water in the inside tank is going to also come out. Okay, so this is pipes and cisterns. I hope you are clear. We will continue this topic some other time with few more questions. Thank you all for watching. Thank you very much. Good day.